Hello everyone, it's Julia, and today I would like to talk to you guys about how you can take the derivative of the inverse of trig functions. So first I would like to start off with the inverse of sine x. So we have y equals the inverse of sine x here, and then if we switch these two variables, the inverse sign will just disappear. So we'll have x equals sine y, and I would like to explain to you guys why the power of negative 1 disappears if we change the variables. So if we have a and b in the circle and the numbers 1 and 2 in this other circle, and if fa is equal to 1, what would the inverse of f1 be? Well, this would be a, because the fa is equal to 1, and so the f, this is the f, and when we're going back, it's the inverse. So the fa equals 1, and the inverse of f1 is equal to a. So for the fb is equal to 2, and so the inverse of f2 would be equal to b, just like the first one here. So the b is going to 2, and so it's fb is equal to 2, and so since we're going back, the inverse of f2 is equal to b. So in this case, the fx would be equal to y, and so the inverse of fy would be equal to just x. So as you can see, when we changed the variables, the x and y, the inverse sign just disappeared. It came down, and so that's why the inverse sign disappears. So we have x equals sine y over here, and then if we take the derivative on each side of this equation, then we would get 1 times dx equals cosine y times dy. Then if we take if we divide dx on both sides and solve for dy over dx, we would get the dy over dx as 1 over cosine y. And then if we go back here in this equation, then with this equation we can make a triangle. So the theta is y, and the sine y, we know that sine y is equal to the opposite over the hypotenuse in this triangle. And as we can see, the sine y is also equal to x, and so we can put this equal to x over 1, since x over 1 is just basically x. And so this here will give us the opposite as x and the hypotenuse as the 1. So here is the opposite side of this triangle. So the opposite is x, and the hypotenuse is in this side. So this length is 1. And now using the Pythagorean identities, we can find the value of the adjacent side. So this is a right triangle. That's why we can use the Pythagorean identity. And so the Pythagorean theorem. So if we use the Pythagorean theorem, we get the square root of 1 minus x squared for the adjacent. So now the cosine y that we have here, the cosine y is equal to the adjacent over the hypotenuse, right? So we can use this triangle to find the value of the adjacent and the hypotenuse, since the theta is the same, the angle, so they're both y's, and so here in this triangle, the adjacent is square root of 1 minus x squared. And the hypotenuse in this triangle is 1. So we put the 1 here, and this is just equal to square root of 1 minus x squared. And so if we just substitute this into the cosine y here, we would get 1 over square root of 1 minus x squared. So now we found the value for the derivative of the inverse of sine x. So this is equal to the derivative of the inverse of sine x. So now that we have found the inverse of sine x, I would like to move on to the derivative of the inverse of cosine x. So I'll actually just leave this so you guys can see it again. So we have y equals cosine, the inverse of cosine x. And now again, if we change the variables, then the inverse just drops down, so like here. So that would give us x equals the cosine y. So now if we take the derivative on each side, then we would get 1 times dx equals negative sine y times dy. So the derivative of cosine y is this. So then if we if we divide dx on both sides and then solve for dy over dx, that would give us the dy over dx as negative 1 over sine y. And now, if we just go back to this equation here, we can make a right triangle. So again, the theta here, the angle is y. So write the y here, and this is a right triangle. And we know that the cosine y is equal to the adjacent over the hypotenuse. And here, this states that the cosine y is equal to x, and so equal to x over 1, since the x over 1 is also just basically equal to x. And so in this triangle, the opposite, the adjacent is on this side, and so the length here is x, and the hypotenuse is on this side, so the length here is 1. And using the Pythagorean theorem, we can find this side, the opposite. So that would give us the square root of 1 minus x squared. And now the sine y is the opposite over the hypotenuse, and we can use this triangle to find these two lengths. And in this triangle, the opposite is square root of 1 minus x squared, so square root of 1 minus x squared, and then over the hypotenuse, which is 1. So this is just equal to the square root of 1 minus x squared. Now we can just substitute this into the sine y here. So dy over dx is equal to minus 1 over square root of 1 minus x squared. So square root of 1 minus x squared. And so we now found the derivative of the inverse of the cosine x. So now we found what we've been trying to solve for. So now that I have explained to you guys how you can find the inverse of the cosine x, I would like to show you guys how you can do it for the tangent x too. Again, I'll just leave this since you might need it again. So we have y is equal to the inverse of tangent x, and again, if we change places with these two variables, the inverse sign just disappears, so x equals tangent y, and then if we take the derivative on each side, that would give us 1 times dx equals secant y squared times dy. So the derivative of tangent is secant squared, and in this equation we would have to divide dx on both sides and then solve for dy over dx, which we would get 1 over secant y squared. And now if we look at this equation that we got before, we can again make a triangle with it. So the theta is y here, and we know that the tangent y is equal to the opposite over the adjacent, and here it says that the tangent y is equal to x, so we can set this equal to x over 1, since x over 1 is just equal to x. And so here it's saying that the opposite in this triangle is x, so this side is the opposite, and the adjacent is 1, so this side is the adjacent. And now, since this is a right triangle, we can use the Pythagorean theorem to find the side of this, the hypotenuse. So we have 1 plus x squared, the square root of 1 plus x squared. And now we can actually change the secant y squared in terms of cosine x and cosine y. And the secant y is equal to 1 over cosine y, since they're reciprocals, and we're squaring it, and so if we square it, that would give us 1 over cosine y squared. So we're going to just replace this with the secant y squared, which would give us 1 over cosine y squared. And then if we just simplify this more, that would just leave us with the cosine y squared. And we know that the cosine y is equal to the adjacent over the hypotenuse. And we can just use this triangle to find the length of the adjacent and the hypotenuse, since they have the same thetas, the y. And so in this triangle, the adjacent here is 1, so 1 over. The hypotenuse is square root of 1 plus x squared. And so we have this as the cosine y, and so we can just substitute it into the cosine y here. And so we would now have 1 over square root of 1 plus x squared, and then we square it because the cosine y is actually supposed to be squared. And if we square it, that would leave us with 1 over 1 plus x squared. So now we found the answer to the derivative of the inverse of the tangent x. So the derivative of the inverse of the tangent x is equal to 1 over 1 plus x squared. 1 over 1 plus x squared. So now I found the derivative for the tangent x. Now that's done. So thank you for watching. I hope you guys learned something from this. So goodbye.